theorem of angle between tangent and secant that we are going to learn. Okay. Now in that, you can see the diagram now here. If an angle has its vertex on the circle, its one side touches the circle and the other sides intersect the circle in one more points. Okay, then the measure of the angle is half the measure of its intercepted arc. Correct? Very important formula. Is it clear? And it is somewhat different from inscribed angle. Is it clear? Here one, that's why the name itself given, tangent and secant. AB is the secant and EC is the tangent. That's why its name is given theorem of angle between tangent and secant, because one tangent and one secant is present. Correct? So how we are going to write this? Angle ABC, you can see in the diagram, angle ABC is equal to half of major arc ADB. You can see properly? Is it clear? Okay. Next. If an angle has its vertex on the circle, its one side touches the circle and the other intersects the circle in one more point, then the measure of angle is half the measure of its intercepted arc. That's why I told you AB is the secant, EC is the tangent, and B is the point of contact. Now angle is formed, angle ABC. So angle ABC is half of the major arc A. You can see here arc. You can see here arc. Correct? Arc ADB. Theorem of internal division of chord. Okay. Now see the diagram. Here, what is given? Can you tell me? Theorem of internal division of a chord. What is given? Chord AB and chord CD of a circle is given. What we have to prove? We have to prove that AE into EB is equal to CE into ED. Again, I am repeating what we have to prove in the theorem of internal division of a chord. AE into EB is equal to CE into ED. You can see properly how the chords intersect internally. So this we have to prove. Let's see the proof. Okay. Are you ready now? Sure. Let's start. We have to construct first. Draw segment AC and segment BD. We have to join it AC and BD. Now, in proof, we are going to see in triangle CAE and triangle BDE. You can see two triangle is there. One is triangle CAE and triangle BDE. Correct? In that, AEC is equal to angle DEB. You are seeing properly because it is opposite angle. Here and here it is an opposite angle. So angle AEC congruent to angle DEB. Reason is vertically opposite angle. Correct? Angle CAE. See properly. Angle CAE. See here. Angle CAE congruent to angle BDE. Angle BDE. Is it clear? Angle BDE. You can see here angle BDE. Reason is angle inscribed in the same arc. We have seen this reason. So both the triangle is similar by AA test. Therefore, once the triangle is similar, their sides are proportional. Correct? So we are going to take in a ratio, that is AE upon DE is equal to CE upon BE, because corresponding sides of similar triangle. We know that, we have learned in the first chapter, when the two triangles are similar, their sides are proportional. Correct? So we are going to use that rule or formula. Now, by transposition, BE will move to the side AE. So it becomes AE into EB is equal to CE into ED. Correct? It is very important. So you have to note down this. Is it clear? Okay. Now we are going to see one more theorem, that is external division of chords. Okay? Theorem of external division of chords. Let's see. First of all, diagram we will see how the two chords intersect outside of the circle, where it is intersecting outside of the circle. Correct? AE and CE, they are meeting at a point E. Is it clear? If secant containing chords AB, you can see the chord AB. If a sequence containing chords AB and CD of a circle intersect outside the circle in point E. Okay, you want to see it now. Then, wait, maybe you are not. Okay, so you can see it properly now. If a secant containing chords AB and CD of a circle intersects outside the circle, where they are intersecting outside of the circle, that is point E. Okay, then how this formula work? AE into EB, one step full AE, secant AE, then back EB is equal to CE, full secant CE, and then back ED. Correct? Now we have to construct, we have to join AD and BC. Correct? We are joining AD and BC. Okay? So you understood up to here? Okay. Very good. Very good. Okay. Now we will do one activity. So you are ready? Okay. Let's start. We have to complete the proof. Okay. So you have to do one activity. So you are ready now? Okay. Let's start. See the diagram properly. It is internal division or external division? Yes, it is an external division of chords. Correct? Okay. Now, in triangle ADE, see the diagram properly. In diagram ADE and triangle CBE. It is visible to you properly? Okay. Now, tell me the answer of this. Angle AED congruent to dash angle. And it is said that it is common angle. I want the answer. Yes, many students have given. Still I am waiting so that all students can give the answer properly. Yes, very good. Continue. Yes, that is correct. Angle BEC. It is correct. Angle BEC. Angle AED. Angle AED is equal to angle BEC because it is common angle. So same angle will be formed here. Clear cut it is mentioned common angle. Correct? Yes. Next we will see angle DAE congruent to angle BCE. Can you tell me the reason now? First. Yes. Angle form on the same arc. Correct. Angle form on the same arc. Next. Shall we move to the next point now? Yes. Okay. As we know that AE upon dash is equal to dash upon dash. Tell me the reason now. Now both the triangle is similar by AA test, correct? We get two angles. So both the triangles are similar by AA test. Then what will be the ratio? Can you tell me now? What will be the ratio? AE upon dash. Fast. AE upon, yes. Answers are coming. Okay. Let's see. AE upon CE is equal to ED upon BE. Okay. Corresponding sides of similar triangle. The reason is corresponding sides of similar triangles. Next. Can you tell me what is the reason now? Last one. Yes, very good. AE into BE is equal to CE into ED. So maximum students have replied. Very good. Now we are going to see one more theorem, that is tangent secant segment theorem. Okay? Tangent secant segment theorem. Is it clear? Here, if you see the diagram in a textbook, you will get point E. I'll show you the diagram also. Point E is the exterior of a circle. Can you see point E? Okay. Point E is in the exterior of a circle. A secant through E intersects the circle at point A and B, and a tangent through E. You can see a tangent. A tangent through E intersects the circle at point A and B, and a tangent through E touches the circle at point T. Then what we have to prove? EA into EB is equal to ET square. Again I am repeating. EA into EB is equal to ET square. Now I will show you the theorem. Okay? Construction. We have to draw T. We have to join TA and TB. Correct? You are seeing in a dot lines. Means it is a construction. Okay. Now in that construction, we have to start the proof. Okay. In triangle EAT and triangle ETB, you are seeing two triangles. Note down these two triangles, triangle EAT and triangle ETB. Now see that, what is common angle between them? Can you name it? What is common angle? That is angle AET and TEB. They are common angles, so they are congruent to each other. Now we have learned tangent secant theorem, correct? So we have to use here angle ETA is equal to angle EBT, tangent secant theorem. So two triangle we got in a two angle we got in a triangle. So both the triangles are similar. Triangle EAT similar to triangle ETB by AA test of similarity. Is it clear? Khushi. Concentrate here. So you will understood. We have seen, you can see here two triangle. Yes or no? One triangle is EAT. EAT. This is one triangle. And second triangle is ETB. ETB. Okay. Now you can see the common angle. Khushi, you can see the common angle where it is. Okay. Now, if you recognize the common angle, just before that we have seen tangent secant theorem. One tangent, one secant. Correct? So angle ETA congruent to angle EBT. Tangent secant theorem. Now two angle we got. So both the triangle is similar by AA test. And once the triangle is similar, their sides are proportional. Is it clear? Okay. Now, so we will write the ratio of that. ET upon EB is equal to EA upon ET. That is corresponding sides of similar triangle. Now here, EA into EB is equal to ET square. As you know that, which property we have used here? Can anyone tell me? Transposition. Yes, Sanskritists also have given the correct answer. Transposition. We are using here transposition. Let's start the practice set 3.5. Are you ready? Let's start. Practice set 3.5. Okay, some technical issues there. Let's start now. Practice set 3.5. You can see the figure here. What you can see here? Ray PQ. You can see ray PQ. touching the circle at point Q, correct? Seeing or not? So PQ touches the circle at point Q. Okay. Now here something is given. What is that? PQ is 12, PR is 8. Find PS and RS. Okay. PQ is 12. It is 12. PR is 8. PR is 8. Now we have to find PS. Okay. So which theorem we are going to use here to find PS? Yes, very good. Tangent secant segment theorem. Tangent secant segment theorem that we are going to use. Let's start. PQ square is equal to PR into PS. Correct? The value of PQ is given. What is the value of PQ? So what is the 12 square? Yes. So PQ is given. So let's substitute that value. 12 square is equal to, the value of PR is also given, 8 into PS. Now we know that 12 square is 144. Is equal to 8 into PS. 8 is right side of equal to. So let's take to the left hand side and divide it. Is it clear? So PS is equal to 144 divided by 8. So what is the answer now? PS is equal to 18. Correct. PS is equal to 18. Very good. Now we have to find out RS. Now how we are going to RS? Let's see in the diagram. PS we know, correct? It is given. PS we have just found, correct? It is 80. PS is 80. PS is equal to PR plus RS. We know PR, that is 8 plus RS. Okay, let's see. PS is equal to PR plus RS. We know the value of PS, that is 18, and we know the value of PR, that is 8. So 18 is equal to 8 plus RS. Take 8 to the left hand side, it will subtract there. So RS is equal to 18 minus 8. Therefore, RS is equal to 10. Yes. We are going to move to the second question. Okay. In the figure, one diagram is given. In that diagram, you can see that MN is a chord and RS is a chord. They are intersecting at point D. You can see the diagram properly, yes or not? Correct? So
Hello, Moto.
Okay. Now you can see. Hello. May I audible now? Am I audible now? Rashmi teacher. Okay. So let's see what is. It is 4, MD is 8, and we have to find out DN. Okay. By theorem of intersecting chords, MD into DN is equal to RD into DS. We know the value of MD, that is 8, DN as it is equal to RD, that is 15, and DS, that is 5. So we will substitute this value. 8 into DN is equal to 15 into 4. So 8 will come to the right side and divide. Is it clear? So DN is equal to 60 upon 8. So DN is equal to 7.5. Is it clear? Okay. Come to the next question now. Here we will see the by theorem of intersecting chords. Similar type of question we are going to see again. MD into DN is equal to RD into DS. We know what is MD, that is 9 into DN, it is 8, is equal to, see in the diagram, RD. RD means what? RS minus DS, correct? So we have substituted here. You can see here. This is RS. From RS, if you substitute DS, we will get RD. Okay? So RS minus DS into DS. Now substitute the value. 8 9s are 72 is equal to the value of RS is 18 minus DS into DS. Now open the bracket. Open the bracket. You will get equation type, quadratic equation type. Okay. So 72 is equal to 18 DS minus DS square. Because when it, which property we have used here? Can you tell me? Which property we have used? Yes, distributive property. Correct. So 18 ds minus ds square. Now what we have to do here? We have to write in a standard equation. Okay. So it becomes ds square minus 18 ds plus 72 is equal to 0. It becomes a quadratic equation. Now factorize. Take out the factors fast. Fast. Factorize it. Yes. Very good. So when we factorize, here the product is 72 and sum is minus 18. Is it clear? So ds minus 12, ds minus 6 is equal to 0. Okay? Because when minus 12 minus 6 minus 18 and minus 12 into minus 6, 72. Is it clear? So when we factorize, we get the factor ds minus 12, ds minus 6. ds is equal to 12 unit and ds is equal to 6. Is it clear? Yes or no? I am audible to you? Tell me fast. Okay. You can see the diagram here properly. Okay. Wait, huh? Okay. There was some technical issue, light problem, network problem. As you know that it is online class. So there will be some. Now you can see the screen properly. Rashmi teacher, see properly. My screen is visible or not?
Yes, sir. Yes, sir. So
Okay.
can you please repeat the second sum? Some students are not
Okay.
able to understand that
Okay. Thank you, teacher.
because of network issue. So repeat that one.
I will repeat the second question. Okay. This one, teacher. Just inform me. I think this is the second question. Correct?
Wait. Sir will come now. Wait. You'll then just tell me how many theorems you learn, and they are about the chords. Yes. Just tell me the one by one theorems name. Which theorems you learn today? Yeah, tangent second. Yes. Tangent second, segment theorem. Yes. Very good. Good. Yes, internal division and one. Second one is external division. Very good. So now, wait. Just stop it now. Now just tell me the formula for the external division of a theorem. As sir shown one diagram in explanation, external division of chords. I hope you have that diagram. Bhumi and Shravan. Any doubt? Neeraj, you said me send me, I think, the message of yes, very good. Okay, you raised their hand, Bhumi. That's why I ask you. Yes, Shravan. Any doubt? Good, good. Very good, all of you. Very good. Now this is about the external division. Now the internal division. Internal division of chords. Yes. Good. My voice is not clear. Is it clear or not? Okay. Okay. So this is about the internal division. One more theorem, last theorem, sir, taught you that. Which one is that? Tangent second. Yes. What will be the formula for that? Yes. Very good. Very good. Sanskriti, Neeraj. Yes. Very good. Okay.
Yes. Rashmi teacher, I'm audible to you now. Okay. Rashmi teacher,
Yes, sir.
I'm audible to you now.
Yes, sir.
Okay, I'm trying to connect again to run the PPT. Just wait. Okay. Now my screen is visible to you, teacher.
Yes, sir. Yes, sir.
Okay. Now question number 2. Chord MN and chord RAS. Two chord you can see they are intersecting each other at point D. Okay. RD is given 15, D is given 4. MD is equal to 8. MD is also given. Only one thing we have to find, that is ds by using the formula. Okay. So you have to remember all those formula by theorem of intersecting chords. Correct? Can anyone write the theorem in the chat box? Yes, very good. Now MD is into DN is equal to RD into DS. So you can see out of this 4, MD into DN is equal to RD into DS. 3 thing is given, correct? MD is given, RD is given, and DS is also given. So we have to find only dn. Okay, so substitute the value now here. So you will get 8 into dn is equal to 15 into 4. 8 into dn is equal to 15 into 4. So take dn, take 8 to right side and divide it. Okay, so dn is equal to 15 into 4 divided by 8, that is 60 upon 8. So dn is equal to, we have completed the second question, first part. Now we'll see second part. In the same type of question, rs is given, you can see rs, second chord is given 18. Okay, md is given 9 and dn is given 8. Okay, so we will see the second part of this question. Here I am showing a diagram again to you so that you understood. Okay, by theorem of intersecting chords, you have to write down the formula first. That is md into dn is equal to rd into ds. Now 3 things is given to you. Substitute the value in that. That is 9 into 8 is equal to. Now here rd is not given, but rs is given. So you have to substitute like this way, rs minus ds. When you are subtracting ds from rs, then you will get rd. So we are writing rs minus ds into ds. So you have to open this bracket by the property. Which property? Distributive property. Okay. 8 9s are 72 is equal to 18 minus ds, because the value of rs is given 18. 18 minus ds into ds. Now open the bracket by distributive property. So you will get 72 is equal to 18 ds minus ds square. Correct? It is a quadratic equation. Now write this equation in a standard form. Is it clear? Sure? Okay. Let's proceed. And we will write in a standard form. Therefore, ds square minus 18 ds plus 72 is equal to 0. Now factorize it. Here the product is 72 plus 72 and sum is minus 18. So take out the factor of this. When you are taking the factor, that is 12 into 6. Okay, because sum is minus 18. So we have to write in ds minus 12, ds minus 6 is equal to 0. When we open this bracket, we will get ds is equal to 12, ds is equal to 6 unit. Okay, sure? Is it clear? Shall I proceed now? Okay, good. Now you are seeing one figure. In that figure, the value of PQ is 6, QR is 10, PS is 8. We have to find out PS into PT is equal to PQ into PR, tangent secant theorem, just we have learned. Okay, so we have to use the tangent secant theorem, that is PS into PT is equal to PQ into PR. Now the values are given, some values are given, like PQ is given, QR is given, PS is given. So whatever the values are given, that we are going to substitute in this formula. So 8, because PS is 8. Okay, 8 into PT is equal to 6 into. Now see in the diagram PR. So PR is what? PQ plus QR. So we will write the place of PR, PQ plus QR. 8 into PT is equal to PQ is given, that is 6. QR is also given, that is 10. So 6 plus 10, okay, that is 16. So 8 into PT is equal to 6 into 16. Now take 8 to the right hand side and divide it. Okay, so PT is equal to 6 into 16 divided by 8. Is it clear? So when we divide, we'll get PT is equal to 12. Okay? Yeah, Rumi. Sanskriti, what doubt you have? Sanskriti, what doubt you have, beta? Okay, no problem. Okay. PT is equal to PS plus PS. Okay, time is over. So we will stop here. We will see in the next lecture, and whatever the doubt is clear, whatever the doubt is there, we will clear your doubt. Okay, bye to everyone. Have a nice day to you. Stay home and be safe. Is it clear? Bye to everyone.